So in part 3, I'll give a brief introduction to viscoelastic models. I will not cover everything that's covered in the book, but I'll just look at one particular model in a little bit more detail. So in biology and in many sciences, even in physics, if you are doing a difficult experiment, then things change as you try to measure them. So one approach that people sometimes use is they look at the value and, for example, if they're measuring resistance of something, then they'll attach the meter and the meter is changing, so they'll write down one value either that came up just when they attached the meter or after 1 second or 2 second, a guess, and then sometimes they don't mention that it was changing. Some people will put an asterisk and say this value was not stable, um, and that's not an anomaly. So many things change as you try to measure them. So for example, if you pull a soft material with constant force, the length could increase with time. So there is a very interesting video on viscoelastic silicone rubber. So silicone is a material that's used a lot in biomedical applications, for example, implants. So if you take a biomaterials course, you might find that silicone has many uses in sealing inside the human body. It has, if you make silicone the right way, then it can be non-toxic, and you can adjust its material properties. You can make it softer, harder, more stretchy, less stretchy, and it's pretty strong. Even though if it's not a composite, it can be made to be pretty strong depending on formulation. So um, let's watch this video and we'll come back to the lecture. So you don't need to watch the full video if you're doing this online. If you want to, if you find it interesting, you can watch the full video, but I just suggest that you watch about 30 seconds starting at about 50 seconds.